Okay.
Okay. Well, thank you everybody very much for attending another session of the Past Performance Virtual Chapter. This is we meet once a month, the fourth Thursday of the month, and I'm glad to have you with us for another really good session. Go to the next slide. I'm Carlos Bassi. I'll be your moderator today. The Performance Virtual Chapter has several ways you can follow us. We have a website, a Twitter handle, a discussion list, and an email, so you can get a hold of us in a lot of different ways or communicate with us. And let's go to the next slide. And today, if you require any technical assistance, just raise your hand by clicking on the hand button in the session. You'll see, go through these instructions and you'll see how to ask a question. One of the questions we always get is the session being recorded? And it is, and it will be posted later on our YouTube website. But remember that you can only hear us through your computer speakers. Thank you to SolarWinds. We give a $100 gift card, and they've been a great sponsor for us for many years, so we appreciate that, and we'll be doing that again today. There's a lot of virtual chapters with PASS. We're just one, so go over there to the PASS website and see which other virtual chapters you might like. Some are language-based, some are more about analytics, BI, and a lot of other things. So there's a lot of information out there for you if you go to the PASS website. The PASS Summit this year is October 31st through November 3rd. It's the big conference that PASS holds every year, and this year it's in Seattle again. If you're going or still thinking about going, use our discount code on the screen, and you'll get $150 off the registration price. And PASS is always looking for help and volunteers, and all of us, the people that put together this chapter are volunteers. Tim's volunteering to speak today, and so there's a lot of people who do things through PASS to help each other out, help the community out. So they're always looking for volunteers. Go to the website, you'll see ways you can help. And being a member of PASS is free. It doesn't cost anything. So several ways to get in touch with PASS, and the primary website is at the bottom, www.sequelpass.org, and that's a good place to start. So today's session is SSIS Performance, presented by Tim Mitchell. I've known Tim for a number of years. Tim's one of the top experts out there in the world of SSIS. He always does a great session. I'm looking forward to it today. So Tim, I'll let you introduce yourself some more and take over.
All right, thanks, Carlos. Let me change my slide deck. We'll get over to the meat of the presentation. So first of all, thanks everyone for taking part of your day out to listen to this presentation. We're going to be talking, like Carlos said, about maximizing SSIS package performance. So we'll talk about specifically about some design tips that I've accumulated over the years that help you identify and resolve performance issues within integration services. So a little bit about me for those who don't know me. Again, my name is Tim Mitchell. I'm a data architect and consultant. I'm a data platform MVP for Microsoft, or recognized by Microsoft. I live in the Dallas area, and if you want to follow along, I blog at timmitchell.net, and I'm on Twitter at Tim_Mitchell. The company that I run and manage is Tyler's Data Solutions, where I focus on data architecture, BI, ETL, analytics, and you can find me at tylers.com. A couple of housekeeping items. We will have a little bit of time for questions at the end. We're going to be pretty fast-paced in this presentation. We've got quite a few tips to get through and some demos as well. So we'll reserve a little bit of time at the end. And then the slide deck that you see will be available for download as well. So we're going to run through, I've got roughly 15 different design tips that I'm going to give you on how to build your SSIS packages, how to design your SSIS packages to avoid some of the more common performance issues that you might run into. The first one that I'll offer up to you really doesn't have a lot to do with integration services, although it does manifest itself quite a bit in SSIS. Make sure that you're tuning your sources and your destinations. So it's entirely possible to write an SSIS package that the package itself performs poorly, but most of the performance issues that I deal with, and with respect to ETL built in SSIS, really aren't related to poor design of the SSIS package itself. It's really something that either coming from the source, going to the destination, either we're doing improper data retrieval, we're trying to load to a table with too many indexes. Sometimes we're even using substandard query language, and I'll talk a little bit about that once we get into a little further into the presentation. But be aware that just because the SSIS package is running slowly doesn't necessarily mean it's the SSIS package's fault. It might be something on either the source side or the destination side that's causing that. So make sure that you take a close look at how you're writing your data retrieval queries. Specifically, pay attention to where indexes reside, especially on your source system, but on the destination system as well. If you're, for example, filtering data in any way in your source query, make sure that, if possible, you're doing so in a way that can easily use the existing indexes, so you're not doing an expensive table scan. Other types of issues to look for, some of these are just unavoidable, but do be aware that if you're on a slow network, if you're accessing a server that's overwhelmed on disk I/O, if it's a slow disk, or it's just got too much going on, it's doing a lot of paging or a lot of disk activity, even if your package is well designed, the whole process is going to run slower because it's going to be, it's falling victim to the weakest link in the chain. So if it's a fast package but a slow network, it's going to be a slow package effectively. So the second tip, this is something that I learned. I'm going to give credit to a friend of mine named Rob Farley. He's a fellow data platform MVP down in Australia. And he pointed this out a couple of years ago in a blog post, and I've got the blog post linked at the end of the presentation. There's a T-SQL query hint that you can use on your SSIS queries, or on your SSIS source queries, that can improve the overall throughput of your SSIS packages. What option fast n will do is that for whatever you supply for the number n, it will attempt to, in the query optimizer, it will attempt to get n number of results, whatever you specify, as quickly as possible, even if it doesn't improve the overall flow or the overall throughput of the whole query itself. So I've got in the slightly off-white or yellow text an example of that. So you're still doing the same select that you would always do. At the end of that, you're adding the option fast. In this case, we did 10,000, but the option fast 10,000 to try to get the first 10,000 rows as quickly as possible. I will point out that the goal for this is not to improve the overall speed of that query, but to get the first n number of results, in this case 10,000, as quickly as possible. The reason that is important in integration services is if you think about the time that you spend processing data. So every piece requires some time. So if you're querying your SQL Server database, it takes a little while to get that data. Second up, once it's got that data in its SSIS data flow, it requires some measure of processing time. Sometimes that's a little, sometimes that's a lot. And then once it's processed, it's got to send the data out to its destination. As shown right here, there's not really a lot of overlap in those things. So for the first blue box there that we see, the query time for the time required to get the data from SQL Server source, if it doesn't get its set of results until well into that process, the second item there, the yellow tab, this one is sitting there not doing anything. Your SSIS data flow is doing no work whatsoever. It's just waiting for something to do. So even though each piece may be running as fast as it can, there's not really a lot of overlap typically in a scenario like that. If you use the fast 10,000, what the query optimizer will try to do is line up something like this, where individually all those pieces are running about the same amount of time. It still takes about the same amount of time to get the data from SQL Server. It takes about the same time to process it through the SSIS data flow, and then about the same amount of time to load it to the destination. The improvement in the pattern here is that we've got a lot more overlap there because you're getting that first n number of results to your package more quickly. So the time that your data flow is sitting there doing nothing is significantly reduced. So this doesn't always work on every package. So if you've got a really simple package that looks something like this, the data is really not spending a whole lot of time in the data flow. Transformation is a non-blocking transformation. We'll talk more about that in just a bit. And then once it goes through that, it goes to the destination. The data is not really hanging up or being held up in the data flow buffers at all. But if your package looks like that from that fast, that option, and this is a kind of an extreme example, but we're doing a lookup, we're doing a sort, we're doing another lookup. The data is going to be in that data flow for a while. So to make this package as fast as we can, we need to get this package some measure of data to start working with more quickly. And that option fast end can get that first set of results, even if the overall query doesn't run any faster. So the third tip, I mentioned this just a second ago, blocking transformations. Every data flow transformation that you use will be grouped into one of three categories: either non-blocking, partially blocking, or fully blocking. And they will all use memory a little bit differently. The non-blocking transformations, they don't row count, the derived column transformation that we saw just a minute ago, also the conditional split. And as soon as they get data in, they're applying their transformation in memory and just passing that buffer along. They don't have logically any reason to hold buffers whatsoever. So these are typically very fast and don't take up, don't require a lot of storage space or don't require any sort of a lag to introduce. The partially blocking transformations, it can hold up some buffers as needed. Things like the merge join, the union, that it requires both the left and the right input to be sorted. And it's got to wait for, if it's got data for the left, that if you're sorting by alphabet, for example, you got to get all the input on both sides for A, followed by B, followed by C, and so on. And it will throttle one or the other of those inputs until it gets everything from the other side, if you've got one that's slower than the other. It's not necessarily a problem that it does that, but you do need to be aware that that behavior can, it can slow down in some cases the overall throughput of your data flow. And finally, fully blocking, this is a red light. Everything stops at this one. So things like sort, the sort transformation, the aggregation transformation, and both of your fuzzy tools. If you're using Enterprise Edition, you have the fuzzy grouping and the fuzzy lookup tools available. These will effectively stop all the rows of data. So if you've got 1 million rows of data that you're passing through a data flow, at that sort or aggregate or fuzzy grouping or fuzzy lookup transformation, all the data will queue up there until it can do that sort or aggregation. So don't hear me saying that these are bad. There are some of these that are absolutely necessary in some cases. These are specialty tools, especially your fully blocking transformations are fairly specialized tools. So you want to use those when necessary, but do be aware that they do have some lag implications, some memory implications on the performance of your SSIS package. So tip number 4 is know about those slow transformations. So in addition to the ones we mentioned earlier about being fully blocking transformations, transforms like the slowly changing dimension wizard, the OLEDB command, by nature, because they process data on a row by row by row basis, those can be very slow. And they're, just like I mentioned earlier, they are specialized tools. They're useful in some scenarios, but I'm going to go back a slide, especially on the OLEDB command. This one is far too often confused for the OLEDB source and misused in that way. Both of these, the slowly changing dimension wizard and the OLEDB command, do always process data, almost always, on a row by row basis. So be aware that while they are useful in some edge cases, those really aren't go-to tools for your everyday data integration. Using those slower transformations should be reserved for special cases where we really don't have any other tool to use. We can't do any staging. We can't transform the data in the source and so on. So number 5, this is one that admittedly when I do presentations, I tend to violate because this is really, really easy to revert back into the old way. If you're using a relational source in a data flow, so an OLEDB source, an ADO.NET source, it's got its own built-in table list. So if you connect to AdventureWorks database and you say, I'm going to use the AdventureWorks database source, it's got a drop-down list that will let you pick either the table or the view that you're using. And it's a really, really handy way to get the table that you want, if you want all the rows in the table. There's 2 downsides to that, I guess really 3 downsides to that. First of all, you're always getting all rows in there. So there's no way using that drop-down list to filter ad hoc what data you're getting. You're also doing a select star from. So it's getting every single column in there. Now you may need all rows and all columns, but in most cases, if you're doing ETL, chances are good you want a subset of either a subset of the columns, a subset of the rows, or both, and you don't need all that. So you want to ultimately, you want to touch as little data as possible, which means introducing as little data as possible to your data flow. Because if you introduce more data into your data flow than you actually need, there is a cost associated with that to load that into memory and store that in memory through the duration of the SSIS package execution. So my recommendation here is, instead of using that table drop-down list, use your query window. Both the OLEDB source and the ADO.NET source and the ODBC source as well will allow you to write a query that you can pick and choose both the columns and the rows that you get. And this can be also a reminder that I can use the where clause, I can limit some of the data. This is especially true if the source that you're pulling from is a view, because the way that SSIS gets the metadata for that table or view is that it does an open row set command. That can be very expensive, especially if it's a view, and even doubly so if it's a view of a view. And it's a bad practice to create a view that references a view that references a view. But having worked in ETL for better than 10 years now, I know that very often those of us who are working in ETL, we're just given, here's the data that you need, here's the view or the stored procedure. Very often we're just left with, this is how we get the data. Reduce, as much as you can, reduce the impact of pulling that data. And one of the ways that you can do that, especially if it's pulling from a view, is to avoid that drop down, the table drop down list, and actually write your query and avoid the overhead of having to do that open row set command at the outset. All right, next up, run in optimize mode. This is a data flow setting that will allow you to specify or suggest to SSIS that that you don't want to allocate memory for columns that you're not subsequently using in the data flow. It's important to know that this is the default setting. So if you haven't turned off anything in your SSIS data flow, this is already running in optimized mode. It's already set to this. However, if you inherit a package from somebody else, or if it's one that you created maybe programmatically and some change was made to it, be aware that if you're not running in optimized mode, you could actually be consuming or using more memory than you need to, because SSIS isn't trying to reduce the amount of memory if it's not using a subsequent column downstream. So tip number 7, as much as you can, transform the data in your source query. This applies specifically to when you're pulling data using an SSIS data flow and you're pulling it from a relational source. I've seen a lot of things like this. In fact, I did a lot of this back when I first started ETL, trying to do everything in the data flow. If I'm doing a lookup, if I'm doing aggregation, if I'm doing sorting, try to do everything in the data flow. But the fact is that as much as I dig SSIS, there are things that the database engine will do much better than integration services. The people who are around me that work with me or hear me speak, you've heard me say this a dozen times. Let the database engine do what it does well. If you're doing something like just a regular old join, if I've got table 1 and table 2 in the same database, yes, you can do that in the data flow, but it's going to be in 99 times out of 100 cases, it's going to be faster to do it as a source query from the database engine rather than trying to do that in your SSIS data flow. Things like sorting, certainly lookups and joins, if it's a simple lookup or join on the same database or on the same instance, and your aggregates, your min, your max, your sum, those are almost always going to be less expensive to do in the database engine than they will be to do in SSIS. So next up, pay attention to your concurrent executables. One of the performance tips that I like to suggest is, as much as you can, do things in parallel, but there is a limitation on the number of concurrent processes or concurrent tasks that you can run at any given time. It's a package level setting. The default value is -1, which will interpret that as being the number of logical processors on that machine +2. So in this case, I've got a virtual machine that I'm running here. I've got 4 logical processors. So that +2 is 6. So for any single package execution, that setting will dictate that I can only run 6 executables at any given time. Let me show you what that looks like. Can jump over to Visual Studio. So I've got a package with a number of concurrent executables. All these executables are set to run in parallel, so there's no. See that I've got 9, 10 here. Let me scroll out just a bit so it'll all fit on the screen. So I've got 10 script tasks. I'm going to go ahead and run that. Let me click the start button, and you'll see even though this looks like everything ought to start in parallel, because of the setting that disallows an arbitrary high number of executables to run at any given time. Right now, we're only running 1, 2, 3, 4, 5, 6 at one time. Once those 6 are done, or once one of them finishes up, it'll start up another one, and so on and so forth. So this is just using the default setting. Again, I mentioned on this machine that I've got 4 logical processors, so that 4 plus 2 equals 6. And if I look in my, let me stop the package from running. If I look in the package settings, you'll see that maximum concurrent executables, sort alphabetically so it's easier to find. That max concurrent executable setting is set to the default value of -1. That's where it uses the number of processors plus 2. I can set that to any artificially high number I want to. I haven't tried to max it out to see if there's a theoretical maximum there. But if you find yourself in either of these cases, either you've got a large number of executables in a single package that need to execute at one time, or if you're working on a machine that maybe it's a virtual machine that just doesn't have a lot of logical processors, that's something that you want to pay attention to. And as I mentioned, that's a package level setting. So if you want to override that, you have to override it on a package by package basis. All right, next up, and in the same vein, as much as you can, you want to go parallel. You want to run as many tasks in your ETL as possible. The default design, I think just the way that we as humans think, we think serially, we think one thing after the other, and we tend to design our processes to follow that logic. The downside of that is very often we're underutilizing our ETL servers. I see a lot of ETL servers that maybe they're over-equipped and they never really hit any sort of peak, but there's still a complaint about my packages are not running fast enough. If you run multiple things at one time, you can overcome that by, as long as things are not interrelated or A doesn't depend upon B, I can run A and B at the same time. You want to test this. There's no substitute for testing. I get this question at least once a month. How many packages can or should I run at one time? There is no answer for that because a package is not a unit of work. One package could take down your entire server, or you could run 1,000 packages at one time if they're fairly lightweight packages. Know how your packages are configured, know their impact on your SSIS machine and your overall infrastructure, not just on the SSI side. But testing is critical to determining how much you can go parallel on your packages. All right, tip number 10, don't be afraid to break out of a solution rooted in integration services. As I mentioned earlier, I've been using SSIS for a long time. I dig it. I think it's a fantastic tool. It's easily extensible. There's no problem that I found that I couldn't, no ETL problem that I found that I couldn't solve using SSIS. However, if that's your tool of choice, very often you tend to look at that as the only solution to the problem. But in a lot of cases, SSIS is not the best way to go. If you're loading data from table 1 to table 2 on the same SQL Server instance, very often it's going to be less work, it's going to be less of an impact to just do that as a T-SQL statement. Sometimes doing a merge operation, for example, will be less costly than bringing the data into an SSIS data flow. Sometimes third-party components can work well. And in a few cases, using an external application via the execute process task will actually be a better performing option. So don't assume that SSIS is the only way to solve ETL problems. Even if you're using SSIS as your primary tool, you can use it as an orchestrator to call third-party processes, to call T-SQL tasks, and do some of those things that maybe aren't natively well-performing in SSIS. Next up, keep an eye on your spools. So there's a couple of different metrics that you can look at in integration services. The one particular metric that I recommend you pay a lot of attention to is the number of buffers spooled. It's a perfmon counter. You can also see it if you're using the SSIS catalog. It's one of the counters that you can see in the SSIS catalog. And this indicates that you're taking data that should be stored in SSIS memory and you're physically paging it out to disk. The perfmon counter that you want to watch for is buffer spool. This is a screenshot of where you find that, your SSIS pipeline 11.0. So this is an older screenshot. You're paying attention to that either in perfmon or in your SSIS catalog log counters. All the processes and figure out what it is. But if you've got any was not sufficient on that machine and you're paging out to disk, which is extremely expensive from a performance sizing. So you want to make sure and pay attention to on your SSIS data flow things that I check in integration services. I think I skipped over a slide. Yep, there we go. This is one of the they're always set at a data flow level. The default buffer size is 10 megs. The default buffer max rows is 10,000 rows of data. Add up to 100,000 on the memory. You can go down to 1 meg. If you've got some sort of exceptional data process, for example, I'm working right now on a so I know it's going to use a lot of memory. 1 row of data in that load is not equivalent to just in terms of memory utilization. I may need to widen the default buffer stay within the memory limitations that I have for that data flow as well as for the overall SSIS process. Times the estimated number of rows divided by the default max buffer rows. Two of these things SSIS can know. It certainly knows your row size based on the data type addition. It knows the default does not take into account. So if you've got something that's exceptionally another setting related to this determines how big a chunk. Yellow you'll see highlighted, this is the default value. And in 95 out of 100, you might want to tweak that down. So if your machine is for a lot of log pressure, you can't afford your log, or you want to have it to be either an all or nothing insert. That's a more rare case, but it does. So the first one, this is from the Microsoft Performance loading guide. Maximum insert commit size, if it's larger than the buffer size, which is the default value, that setting is simply ignored and every buffer of data is committed. That's the organic way of handling it. If you set maximum insert commit size to 0, that means the entire, I think I've got a misworded thing there, but the entire set of data is committed in one big batch. So if you've got 10,000 rows, it's going to commit 10,000 rows in one batch. If you've got 10 million rows, it's going to try to commit the entire set of data in one batch. Be careful with that setting, especially on large loads, because you can explode your transaction log on your destination system. So pay attention to that. More often than not, if you're going to change this, you're going to make it the third option, where maximum insert commit size is smaller than the buffer size, which means that you're doing more frequent, not less frequent commits. It'll commit at the end of every maximum insert commit size, whatever that memory amount is, as well as at the end of every buffer. And keep in mind, this doesn't impact the size of the um, preferably, and if you know nothing else about the process, you want to make this assumption. A small number of large commits is preferable. So you want to not change that setting unless you have an acute issue, like this needs to be an all or nothing load. I need to either commit the entire set of data or not, or if you're under intense log pressure and you want to commit in smaller chunks of data. So do pay attention to those. Just a couple of bullets on that. So changing this, the good is that potentially less database overhead by having larger commits, possibly less fragmentation as well, because you're doing larger operations and fewer of those larger operations. The downside is in using a bigger size, your log file can grow, TempDB in some cases can grow as well. All right, I mentioned earlier that you need to pay attention to your buffer's spooled counter. And ideally that number is always gonna be 0, but we want to prepare for the case where it's not. If you physically run out of memory, if you got an exceptionally large data flow process, you wanna make sure that your package is gonna run as quickly as possible. There's 2 settings that you wanna change in your data flow task to make this happen. Blob temp storage path and buffer temp storage path. These define if you need to page out to disk either as a blob or if you got a buffer overflow and you can't fit it in memory, it needs to spill out to disk. This is the location where it writes to. The default setting is a blank, like we see here. If you don't specify anything, it's going to drop that into one of your Windows temp directories, which is probably on your C drive, which is probably the biggest or the busiest disk on your system. That's most likely the worst place you want to have that. Put it on a fast or a less busy disk where possible. Again, you don't want it to get to that point, so consider this to be, this is like your backup parachute. Your parachute is we don't want anything paging out to disk anyway, but your backup parachute is if it happens, I want it to be on the fastest disk possible to minimize that impact. So next up, managing your lookups. Make sure that you know your lookup types or your lookup cache modes. This is fairly important because you'll see a lot of memory related or performance related issues around how you're using the lookup transformation in SSIS. Full is the default. Partial is a setting that you can use to partially cache, and then none. We'll talk about each one of those. Full, as I mentioned, using full cache is the default. This means that whenever you introduce the lookup transformation into your data flow, if you write the query in that lookup transformation to say, I want to pull all employees or all products or all sales for some period, it's going to take that entire set of data for whatever query or table you specify. Going to do a full cache and fully cache every bit of that data. So if it's 10,000 rows, it's going to move rows into the SSIS memory space. 10 million rows, it's going to do the same thing and move it into SSIS memory space. Now, once it's over there, the data flows really quickly because all of your lookups, all your comparisons are done directly in memory. The downside is there is some overhead to moving that over into the SSIS memory space. Partial cache, this will move, so it does still do the caching like we described earlier, but partial cache will only do every distinct value that you encounter. It will move those on a value by value basis. And what I mean by that is if you're looking up, say, sales of, so if you're a large online retailer and you sell 10,000 instances or 10,000 sales of a given hot product, if you're running that through a lookup transformation and you're validating that yes, 1234 is in fact a valid product ID, the first time it finds 1234, it's going to make a round trip to the database. It's going to go look at that database that you specify in the lookup transformation and say, give me product 1234. It's going to find it. Yes, it is indeed there. At that point, it will cache 1234 in the SSIS memory. Or 1234 is the product ID. It doesn't make that expensive round trip to the database. It'll just use the in-memory, will be cached in SSIS memory, and then subsequently the memory copy, the in-memory cached copy. Finally, no cache, just like the name implies, doesn't cache anything at all. So if you're using the lookup transformation through that data flow, it's going to make 10,000 round trips to the database to look up the values. Very, very few use cases are actually merit fact and dimension load running at the same time, which in itself is not a great practice. But you want to do that fact load to get the most recent version of that dimension, even if it's been loaded after the load of that fact package has started. That's really the only, and admittedly, that's kind of an edge case, but that's really the only case that I can think of that you might want to use no cache. In 10 plus years of using integration services, I can count on one hand with fingers left over the number of times I've ever used the no cache setting on purpose in the lookup transformation in SSIS. So we'll take a quick look at how that looks as far as a demo. Jump back over to Visual Studio. So I've got two packages configured here. I've got one of them that's doing just the conventional lookup. So on my data flow, I'm looking up salary information. I'm querying my source database, doing a lookup against my employee information, and I'm writing that data out to a flat file. So I'm going to go ahead and run that. So the package will start, and it looks like it's not doing anything at all. It's going to hang here for a couple of seconds. We don't see visually, we don't see any data flowing through here. If this query were a fast query, it should have been pushing data through already. So if I jump over, don't quite know what's going on, so let me jump over here and see on my output window. Looks like my monitor resolution has wrecked the text a little bit, but on my output, under the lookup transformation, I can see that, sorry, my zoom tool is running a little bit slowly today. I can see this is what's happening. So on the lookup transformation, it's caching a few hundred rows, a few million rows, millions more. So it's caching altogether 6.2 million rows of data. That's what the, now altogether, I loaded just a relatively small amount of data. It loaded less than that it took to do that. It took about 30 seconds to run that, half seconds to run that load. So that's using the default setting. Let me jump back to the data flow. That's using the default set full cache lookup. It's bringing that entire set of data into the SSIS memory space. Before it does anything else, it caches of data and pushes it across. So for So different package here, same source, same destination, same metadata, same lookup transformation. The only thing I'm doing differently here is I'm using, instead of full cache, I'm using the partial cache. So it will cache not the entire set of data, it's going to cache value by value. For every distinct value that we find, it's going to cache those distinct values as we see them. First thing that we can observe here is that immediately, we didn't see this before, immediately we see the first buffer of data, just shy of 10,000 rows of data, immediately go to the lookup transformation. And we can see some progress where this early in the execution last time, we didn't see that. However, this is still not running terribly fast. So this is, it's 29,000 rows in. It's been running for about 15 seconds, maybe 20 seconds. This is, I can tell already just the speed at which it's going. This is going to run more slowly than the other package because that lookup transformation is doing a row by row by row lookup on every distinct set of value, every distinct value that it finds. I'm going to go ahead and kill that because we're not even halfway done and we've more than exceeded the time that the other one ran. So we can't necessarily assume that in this case we had partial cache, the other one was full cache and ran faster. We can't assume that that will always be the case. If I had a really small set of data, so if I had this 6 million row lookup table and 1,000 rows of data in my source, chances are good that would give it more of a run for its money, or possibly the partial cache would be faster because it may be faster to do a few hundred, maybe up to 1,000 lookups on a row by row basis, be moved from SQL Server over into SSIS memory before those lookups can take place. This just like anything else, and more importantly, it requires knowing your data. So you can't assume that one design pattern always works. You can't assume that using full cache, which is the default, will always be faster, because frankly, it's not always going to be faster. Knowing the size of your data, the volume of your data, and how many values are repeated versus how many are distinct in that lookup transformation will help you make a decision as to which one will perform better. All right, next to the last tip, share the road. So make sure that you're paying attention to what other processes are running. So in a perfect world, I like to tell my clients this: if budget and time are not an issue, build a server that all it does is integration services. And your sources and destinations, when they're running ETL, that's the only thing they're doing. Now, very, very infrequently does that really happen, because money is an issue. SQL Server licenses are not cheap, hardware is not cheap, and manpower to maintain them is not cheap. So very often we're working or possibly even SSIS machines that are running multiple roles. I've dealt with at least one integration services machine that was also a domain controller. Please don't do that. If you've got that, call me, I can help with that. But there are other processes very often that run on integration services. So consider how your processes are cooperating with other things that are running on the server at the same time. If you've got a midnight to 4 a.m. ETL window, you don't want to start everything at midnight. So try to stagger out your processes, both the ones that you control and the ones that you don't, so that you're not overwhelming the server with anything at any given time. And then finally, pay attention to staging of your data. So this is one of my favorite patterns. Taking data that needs to be updated, whether if it's relational data, if it's data coming from XML or flat file or some other non-relational source, very often you'll be tempted to, instead of trying to stage it, just go ahead and do your update directly in integration services data flow. So using that OLEDB command that I mentioned a little bit earlier, possibly the slowly changing dimension wizard, you can do those types of operations directly in the data flow. However, there's a performance penalty to be paid for that. If you can stage your data and let the database engine do what it does well, if you're trying to join together data for an update, I promise you the database engine in a T-SQL query, or even other relational engines, if you're on Postgres or MySQL or whatnot, staging data rather than trying to do those updates directly in the data flow is in almost every case going to be faster on that SQL statement rather than using the SSIS data flow for that. All right, show you a quick demo on that. So I've got two examples here. One of them we may not actually be able to finish because it just takes a while to load. So on my data flow, this is what I'm doing. I'm pulling in a flat file. I've got a flat file with some emails, and I'm using the OLEDB command, which is a tool suited for inline updates. So what we're doing here is I'm doing a live update. Every row of data that I process, it's doing an update on my people table. It's going to set my email address equals question mark, where phone equals question mark. And those question marks come from columns in that input file. So param1 and param0 are email and phone respectively, and those are what we're using for the updates. We'll go ahead and kick that off. This is a fairly small set of data. I want to say we've got about 15,000 rows of data. One of those. Pretty quickly we see that it passed off. It's using a buffer. What's happening right now is that OLEDB command is not running a buffer or a batch operation. It's buffer. We got the second buffer now. So for 15,000 rows of data, it took about 24 seconds to run that. Got 150,000 or 1.5 million. This will not scale in a linear fashion. It's going to scale exponentially because you're set based. In a case like that, adding a little bit of extra overhead rather than just doing one operation, a staging table that I'm truncating before we start. For some reason, my zoom in is really previously created. in my data flow operation, instead of trying to do that live update using the OLEDB command, that staging table that we previously discussed. And then once I write into that, I'm letting the database update on a row by row basis. Now I'm doing the update based on joining together the people that I just updated in the previous set. So before we saw that this took, so kick that off and see if this runs, even though it's got moving parts, if that runs any faster, and 3 seconds. So a little over 10% of the time it took to do the other load. This one ran in that in just about a tenth of the time. So even though there are more moving parts, it took a little extra time to set up. This is a much better performing operation. So don't be afraid to do things like that, even though it's not the pure SSIS way to do it. This is certainly a faster way to do it. It's going to be much better performing for most of your T-SQL or for most of your ETL operations. So a couple of additional resources. I recently published an SSIS Performance design white paper. It's free to download if you want to go download that. A couple of things I'll point out. I mentioned Rob Farley, and that's a short link out, as well as I made a guide, which is a couple of years old, but still very valid in terms of large-scale data operations. And with that, that's all I've got. Carlos, if you're still on, I'm going to pass it back to you to address any questions that we have.
Hey, Tim, can you hear me okay?
I can hear you.
Okay, good, good. We do have several questions, so I'll just try to pass them along as they came in to us over here. You may have mentioned this, but a couple of people asked about your slide deck, and do you post it? Would they be able to access it?
Yep, absolutely. So the slide deck will be available afterward. In fact, if you guys,
okay.
Carlos, I don't know if you guys have a distribution means to do that. We can publish it on the YouTube channel if you want, or I can just put it on my website and you can download it from there.
Yeah, I think both, right? We could upload it to YouTube with the session, and then you know, if you could tell people it's on your website, then that's fine too, and people can go there. So.
Yep, we'll do it.
Okay, so first question we had is, are there any advantages to using stored procedures over queries using tables and reviews?
That's a common question. So any advantage of using a stored procedure as opposed to a table or a view? So honestly, I prefer using the table or view for one simple reason. I have more control over the data that I get back. So I can filter the number of columns, I can filter the number of rows that I get to tailor only what I want in my execution or in my SSIS package. If I'm dealing with a stored procedure, very often I'm limited to what that stored procedure provides, and I really don't have any operational control over that. From a performance perspective, I really haven't noticed any difference whatsoever between using just a regular query or using a stored procedure, because under the covers, they're both T-SQL commands. They're both just relational database queries.
Okay, and kind of along the same lines, is there any difference between using the OLEDB destination or SQL Server destination?
Oh, that's a great question. So the SQL Server destination, honestly, I'm not even sure that it's still in integration services in the more modern versions. The SQL Server destination, when it was released in earlier versions of integration services, was designed to be an extremely fast destination if you're doing just integration services operations. And I did find that in some limited testing that it did have a little bit of a performance gain. However, it was extremely finicky. There were lots of qualifications that you had to have to use it. For example, the SSIS package that it was running on had to be on the same instance as the server that you were loading to. And just the configuration about it was really finicky. Honestly, I used it maybe a half a dozen times and found that it was so problematic and so fragile that I finally gave up on it. And I think I've maybe seen it 2 or 3 times in the last 5 years out in use in the wild. There's just hardly anybody using it because it has been so finicky.
Okay, well, thanks for that. A few more questions, maybe 2 or 3 more. What's the difference between, you probably get this one some too, I would guess. It seems like a lot of people wonder about this. What's the difference between rows per batch and maximum insert commit size? And should one always be larger than the other?
So what's the difference in rows per batch and the maximum insert commit size?
That's right.
So the rows per batch, I'll be honest, I don't think I've ever changed that whatsoever. The rows per batch it's defining a number of rows as opposed to a memory size. Maximum insert commit size is the amount of memory, or how big altogether that data is. And what I want to say, I may be incorrect in that, but I believe it uses the lesser of those 2 values. But again, in all the troubleshooting that I've done in integration services, I've never manipulated rows per batch. If I need to manipulate something at that level, I'm manipulating the maximum insert commit size because that's a more predictable output.
Okay. Is there, let's see if I got this right. Is there a way to add a column to the build insert task if a new column is needed? I'm not sure I understand the question, but maybe you do.
So I think I might. If the question is if a new column appears in, is there a way to make it automatically appear in the integration services data flow? The answer is no. Meaning that whenever you create and save the package, that's where it actually writes the metadata and stores. Columns are introduced, if columns go away, it will in most cases actually break the ET.
And that's true for bulk insert as well, right? I think that was the clarification they were asking for. Let's see, I think we have one more question, unless another one. And the SSIS, can you load data into Azure, and can you connect to?
Yes, the answer is yes, absolutely. Especially on later versions of integration services, there are connect to Azure Blob Storage. You can connect to, I know you can do data lake tasks as well, which is a separate add-on. It's a free download add-on for integration services. And in fact, I'm doing a PASS Summit for those of you who are going to the PASS Summit on in the cloud, and it's titled SSIS Things, Connecting to Cloud Data Sources, Running a Virtual Machine in Azure in the cloud using SSIS. And more recently, just earlier this week, Microsoft announced that they have just come out with a public preview of SSIS running as a PaaS service. So you can run basically SSIS as a service where you couldn't do that before.
Let's see, well, we have time for 1 or 2 more. So 1 or 2 more actually popped up here on the screen while you were talking. Let's see, there seems to be a lot of interest, right? So there's always a lot of things to be learned about SSIS. So it's good to go through some of these questions.
Sure.
Somebody's asking, what if new rows are added to a table after a data flow starts? Will they be included?
Oh, that's a good question. So what if new rows are added after the insert starts? So the short answer is it depends. It doesn't, a source will not lock the entire table for the duration of the operation, but if those rows are committed before the last batch of data has been pulled out or the last buffer of data has been pulled out, they absolutely will be included, yes.
Okay, and I guess we'll make this the last one. You mentioned the Microsoft Data Loading Performance Guide.
Yes.
And Somebody's saying here they must have looked it up during the session. It says it references SQL 2008. So I would ask you, do they have the right one, or is that still relevant in today's world?
That actually is the right one. So it was published several years ago. A lot of the aesthetics that they talk about they have been updated, but as far as the core concepts, those are still relevant. I would love to see a more updated version of that because I think there is some additional content to be had. But for right now, that is the only version. As far as I know, that's the only version of that. They haven't done a formal update of that.
Okay, well, I think that's all we have today. I really appreciate it, Tim. It's always very informative when you talk, so thanks a lot for all this information. I know you squeezed a lot into the time we had, so really appreciate it.
My pleasure.
Thank you very much.
All right, thanks.